In this video, we'll examine the graphs of functions, and also we'll consider tests called the vertical line test and the horizontal line test. Now first, I'm going to draw an example of a function that we looked at in the past. Every input leads to one and only one output. Let's have each number match with itself. So 1 leads to 1, 2 leads to 2, 3 leads to 3, and 4 leads to 4. These are the inputs on the left and the outputs on the right. The letter that goes along with inputs is X, and then the symbols that go along with outputs would be, in function notation, f of x. So the rule that's being followed here is f of x equals x. Every output equals the input. Now, our domain here is limited to just 4 integers. But in reality, it's possible to have a larger domain. I'm going to plot these particular coordinates on a graph using Desmos.com. First, let's write out what the coordinate pairs would be. We said that 1 leads to 1, 2 leads to 2, 3 leads to 3, and 4 leads to 4. The inputs are on the left and the outputs are on the right. Clearly, every output equals the input. Let's graph those points as coordinate pairs now. One comma 1, 2 comma 2, there's 3, 3, and 4, 4. Now you can see a pattern emerging here. And if we wanted to expand the domain beyond what it is now, we could include many more points. We could do, for example, 0.5 comma 0.5 if we wanted to allow fractions. We could have 1.5, 1.5, 1.8, or 1.8 comma 1.8, and this could keep going. What I'd like to do now is come up with a rule which connects all the points. Okay, so I'll do that here. The rule is f of x equals x. This is the function in a graphical form. And now I'd like to do the vertical line test on it. To do the vertical line test, all we have to do is type in a particular x location where we want to test it at. So let's try, for example, x equals 1 for right now. If I type in x equals 1, that creates a vertical line at the location of 1 on the x-axis. And I just want to see how many times my vertical line intersects the curve. I call it a curve. That's common in mathematics, even though in this case it's straight. The function curve is this slanted line. And it intersects just once at the point 1 comma 1. So far our relation passes the vertical line test. We could change our x location though. Let's move to x equals 2. Okay, we see that at x equals 2, our vertical line again intersects the function just once. And that's what we need, actually. Now I can take this slider and move it to the right and left. So what we're looking for here is any place where our vertical line touches the relation curve more than once. And as you can see, it doesn't. So f of x equals x is a function. because it passes the vertical line test. Now let's examine a relation that is not a function. I'm going to type in a formula that creates a circle. It's a circle of radius 1. Let's see if it would pass the vertical line test. If I type in, for example, x equals 0.5, if this is our input, then what is our output? Well, we can see that the vertical line intersects here at about 0.866, and it also intersects down here at negative 0.866. What that means is that there would be more than one output. And you can't have that in a function. That's the problem. So this curve, the circle, is not a function. We can move our vertical line around, and it fails that vertical line test at an infinite number of different positions here. A circle is not a function. And we can also perform what is called the horizontal line test. Let's try a horizontal line test on our function f of x equals x. In order to do a horizontal line test, we just need to type y equals some number. It could be any number of our choice. Let's try y equals 2. This will create a horizontal line, and again, we're just looking for places where the horizontal line intersects with our curve. It only intersects once at a y of 2. So far it passes the horizontal line test. And we can move up and down, and we see that no matter where we're located on the y-axis, we're going to intersect the curve only once. So f of x equals x actually passes the horizontal line test. When you pass the vertical line test and the horizontal line test, then we can say that the function is 1-to-1. Now, interestingly, 1-to-1 functions are a subset of functions. You have to be a function in order to be 1-to-1. Now, how do you get to be identified as a function? You have to pass the vertical line test. Then you get to go inside the black bubble. In order to be a 1-to-1 function, though, you have to pass the horizontal line test. So deciding what type of function we have is a two-step process. So it's a two-step process. First, we do the vertical line test to show that every input leads to one and only one output. If it is, then we have a function. After that, we do the horizontal line test to see if every output is pointed to by only one input. Then the mapping would be reversible if needed, and that is what is called a 1-to-1 function.